Good evening, everyone. We are pleased to welcome our faculty for today, Mr. Felix Emeka Anyam, a seasoned research data expert, data scientist, and biostatistician. He is also a member of the editorial board at PLOS1, bringing a wealth of experience in scientific research, data analytics, and publication standards. Without further ado, Mr. Anyam will now begin his session.
Hi, good afternoon, good evening, everyone. I hope you can hear me clearly.
Yes, doctor.
Okay, all right. So today we'll be looking at descriptive statistics. We have the descriptive component, then we have the inferential statistics component. So today we will focus on the descriptive statistics component and also look at some of the visualizations that are applicable for descriptives. Welcome, everyone.
Thank you.
So what are descriptive statistics? Basically, they are used to summarize the characteristics of a data. You are very much aware that the beginning of a data collection process or a research process involves you creating some form of a hypothesis. You have identified a problem, whatever that problem is if it's a prevalence in malaria, if it's a prevalence in preeclampsia, you want to do a research to see what are the determinants for that condition, what is making pregnant women more susceptible to coming down with preeclampsia. So you have identified a problem, you are now crafting out a hypothesis on what you think may be the reason why they are coming down with preeclampsia. You have designed your tools, you have collected the data. So now the data, whichever platform it is, whether it's in Excel, whether it's one of those fancy databases like in the Google Form, in the Kobo Connect, or in Tableau, or wherever it is, it has to go through the data analytics process, all right, after it has been cleaned. So one of the ways you can summarize that data as at its first instance is what they call descriptive statistics. It gives you like a summary, because looking at that data on a spreadsheet, you may not really be able to make any meaning out of that data. All right. So the descriptive statistics is more like that first phase of the data analytics, where you begin to summarize the data, where you begin to describe the data. Sometimes we use the descriptive statistics process to actually detect if that data is truly cleaned. Imagine analyzing a data for sex, and instead of seeing just male, M-A-L-E, and female, F-E-M-A-L-E, you may begin to see some other spellings. Maybe a male with a double L, or a female with a double E. You can only notice these discrepancies when you first run that phase of descriptive statistics, where you begin to detect some of these anomalies that is showing that that data is not properly cleaned. So the descriptive statistics is usually that first phase, helping you describe that data. All right. So for the data that have the scale of measurement, like the categorical data, you begin to summarize and categorize them in frequency and percentages. For those that are actually numeric, that are actually numbers, you begin to summarize them as means and standard deviations, especially for the parametric data analysis, those data that are normally distributed, you summarize them using the mean, using the standard deviation. But for your data that are not normally distributed, those data that are skewed, you summarize them using the median and the interquartile range. Then for the categorical data, you summarize them, using the frequency and the percentages. So the descriptive statistics is basically at that first point where you just summarize the data the way it is, and sometimes it may help you know which of those values have a higher percentage or not, which of those values have a higher mean or not, those sort of things. And at that first stage, you're able to identify patterns, of course, and you can communicate some form of findings in terms of the summarization kind of findings, saying like so percentage of the people, the social category of the age were highest in terms of their frequency, those sort of descriptive summaries. It can actually help you do that. And one of the examples that I gave here, it's showing you that imagine a study that you're doing with 200 patients. You'll be able to tell how many percent reduction, in the space of the 6 months you have collected that data, because the data you have, you can represent it in such a way that you will be able to tell if you categorize the blood pressure into those that have and those that don't. That means a yes and a no. You will be able to tell the percentage of people that have yes and the percentage of people that have no. So for the fundamentals of descriptive measures, like I had mentioned, if you have continuous variables, those that are numbers, and your data is normally distributed, you can use the measures of central tendency to summarize using the means. Then if it's not normally distributed, probably your data is skewed. And once you have collected your data, it is good to test for normality of data before you begin to analyze that data. So testing the normality of the data, you can use what they call the Shapiro-Wilk normality test. And if you have a p-value that is, significant, that means a p-value that is less than 0.05, then you can assert that that data significantly deviates from normality. So when you run your Shapiro-Wilk and you have a significant p-value, it automatically tells you that the data significantly deviates from normality. So you would not be using parametric method, you'll be using non-parametric. So in that case, you will not be measuring mean, instead you will be measuring median. Okay, and if you're using means, it goes with standard deviation. If you're using median, it goes with interquartile range. All right. For statistical purposes, we don't usually use mode as a summary. Rarely you would find an analysis that is using mode, but you have to appreciate the fact that mode is part of a measure of central tendency, but it's just that we don't often use it in our descriptive statistics measures, but it's a part of it. So apart from the central tendency, you have the measures of what? Variability. You have the range. Of course, the range just tells you the difference between the minimum number and the maximum number, gives you the range. Then you can have the variance, which is the average square deviation from the mean, and also the standard deviation, which is the square root of variance. Interestingly, these things are not calculated manually. When you analyze the data, the statistical softwares have the capacity to actually generate these things for you. So if you're working with numeric data, then you will be dealing with the measures of central tendency and you'll be dealing with the measures of variability. But if you're working with categorical data, example of a categorical data is sex, either they are male or female. Another example is like educational level. No primary education, primary, secondary, tertiary, that's a categorical data. Most of the questions you ask participants and they are giving you a yes and a no answer, or even the Likert scale where you have agree, disagree, strongly, undecided, they are also categorical. All right. It's just that for the categorical, sometimes you can have the nominal and the ordinal, but they are still categorical. Like the sex I mentioned is nominal. You have the male, you have the female. No value is greater than another. The male is not greater than the female. The female is not greater than the male. All right, that is a nominal categorical variable. When you ask people questions and they give you a yes and a no, it's nominal because the yes is not higher than the no is not higher than the yes. It's just their preference at that time. But there are some categorical variables that are not nominal. They are ordinal. They have a scale. They have a pattern. They can increase. Example is the educational level. Even if it's a categorical variable where you represent them using frequency distribution, the counts and the percentages, it still has that ordinal scaling. For no formal education, primary, secondary, tertiary, PhD, postdoc, and the rest of them, you see that there is an increase in educational level from low to high. Some things like stages of disease, stage 1, stage 2, stage 3, stage 4, that's also ordinal. It shows an increase of that categorical variable. So whether nominal or ordinal, they are still categorical, and you represent them in frequency distribution. So you have the frequency, which is the number of counts, and you also have the percentages to represent prevalence in some cases, or to represent the proportional, changes in the different values that you are measuring. It's anyone still seeing the slide? I'm not seeing.
No, I can't see.
Okay, all right, thank you. It's back.
coming now.
Okay, all right, thank you. So the next slide is the descriptive statistics. Visualization, like how do you represent the descriptive statistics? Like I mentioned before, the descriptive statistics is basically describing your data, summarizing your data. It is different from inferential statistics, which we'll be looking at in our next session. This time, which is the descriptive statistics, there's no form of inference. You are not making any inference why something is the way it is, because a lot of times students find it difficult to distinguish between descriptive and inferential statistics. So if this was an inferential statistics, there would be some comparative analysis. I will show you an example of a comparative analysis table. But this table now, you'll be seeing that, like, for example, the table 4.1. I hope you can still hear me. Somebody is saying that they are not hearing. I hope you can still hear me.
We can hear you, but you are not seeing the slide.
The slide is there now. They just shared it again. I can see it.
I'm seeing it.
Okay, all right then. So for how you can represent the descriptive statistics, you can represent it as a table, you can represent it as a visualization. So I've shown an example here that I cropped for one of my work. So you can see the example. I called it table 4.1 because it was the first table in the chapter 4 of that work. All right. So it's titled Social Demographic Characteristics. So you see the age range, you see the mean age, you see the range of the mean of the continuous variable, you see the sex, you see male-female ratio, marital status, educational level. So you can see that I am describing the data, all right? For the data that is categorized, age itself is a continuous variable. That's why if you check below, you would see that I had represented it first as a mean and standard deviation because the data was normally distributed. So the mean age was 33.10 plus or minus 8.47, which is the standard deviation. The minimum age for the participant of this study was 18 and the maximum was 48. But you can see that apart from summarizing the age, because it's a continuous, the age has been categorized intervals of 18 to 25, 26 to 33, 34 to 41, 42 to 49. So as you can see, there's that interval there. So because of that interval, the age has automatically turned to a categorical variable. So the moment you categorize your age, you turn it from continuous to categorical. So you can represent it in frequency and percentages, okay? So how did we get the first percentage, which is the 20.84? You do 45 times 100 divided by 216, or 45 divided by 216 times 100. That would give you 20.84. 62 divided by 216, which is the overall population of the research sample, times 100 will give you 28.71. So that's how the percentages were calculated. So you have the counts. So for sex 2, that is categorical, you can see that we have more males, 195, which gave us a percentage of 90.28 compared to females. The male-female ratio was 9.3:1. So in this sort of study, we found there were more males because it's a study that had to do with musicians, so we had more males than females. For the marital status, it was only single and married. Educational level, it was only secondary and tertiary. There were none for primary, there were none for no formal education. So you can see this is descriptive statistics. You are basically describing the data as it is, all right? So if you're going to be interpreting this data, it will be something like the age range showed that those that are between 18 to 25, were 45, and the percentage of that was 20.84. And those that were within 26 to 33 were 62, which gave us a percentage of 28.71. And you can also summarize by saying that those that were 34 to 41 has the highest percentage. So we had more people that were within the age range 34 to 41, giving us a percentage of 37.04. That's where it ends. That's why it's a descriptive statistics. You don't make any inferences, all right? You don't say, oh, those that were highest were between the age range 34 to 41, which gave us a percentage of 37.04. And the reason why we had more people from 34 to 41 is because they did this, they did that. You are now moving to inferential statistics. You are beginning to infer why your result is the way it is. It is not allowed in descriptive statistics. In descriptive statistics, you just describe what we are seeing in the data. No need inferring why there's more males than females. Just tell us, in this study, we have 90.28% of males and 9.72% of females, and you move on. It is during inferential statistics you will now begin to infer why one is higher than the other, why this is higher than this, why the data is the way it's looking. That's inferential statistics. For descriptive, you just describe the data the way it is. If you're using visualization to describe the data, like for example, you're using the pie chart in this case, you tell us, oh, 90% of them were civil servants, 24% were musicians, 11% were professionals, and you move on. You are not allowed to tell us why you think 24% were musicians or why you think only 18% were students. No, that's inferential statistics. In descriptive, just describe the result the way we are seeing it and move on. I'm seeing a hand, Mira. So I don't know if you will be allowed to ask the questions now, but I think we will have opportunities to do so at the end of the session. Yeah, thank you. So this is another example of descriptive statistics. I got this table 1 from one of my published work. So as you can see, it is descriptive. You describe males, were this number, this is the percentage. Females were this number, this is the percentage. The range between 17 to 26, this is the number they were, this is the percentage. The marital status, singles, there were 5,489 participants that were singles, giving us a percentage of 94.28%. That is it. You just describe the data and you move on. That's what descriptive statistics is all about. And the tables are usually this way: the variable, the values, the frequency or the means, the percentage or the standard deviation. That's it about descriptive statistics. So if you look at the figure that is here, this is another way you can represent your descriptive statistics. All right, this is also from my dissertation, a visualization that I did, because in that study, I collected data from 38 sub-Saharan African countries, but after the data cleaning, I only had 27 eligible countries. And as you can see, Nigeria was represented most in that data, followed by Senegal, followed by Kenya, followed by Malawi. The least country that was represented was South Africa. As you can see there, 2%. Liberia was 2.1, Guinea was 2.5. You move on. That's the descriptive statistics. Nobody's asking you why Nigeria was more. Nobody's asking you why Senegal was more, why you think Senegal was more. Those things can be inferred if you're doing an inferential statistics. But for descriptive, you just describe what you found and you move on. However, if you look at the table at the other side, you will see that that table is different. This table is not a descriptive statistics. So that's why I had to put it there so that you can see the difference. If you look at this table, one thing you would notice is that there's a test of significance. There's a z-test and there's a p-value. The only reason why you would have a test of significance in a table is because you are checking for statistical difference. You're checking if one group differs from another. That's not descriptive now. So if you look at this particular table, you will see that we have two groups here. This is a study that we're looking at the drugs of COVID-19. It was a study that was done during COVID-19 period. So I just cropped the table from the publication and put here. So if you check here, you will see that we use the Mann-Whitney U-test. The reason why we used the Mann-Whitney U-test was because these lab biomarkers, they were not normally distributed. These data, they were skewed because the data was a convenience kind of, it's a data that was collected, not following any probability method of sampling. So most of the continuous variables were not normally distributed. So we had to go with non-parametric method of data analysis, which is using the Mann-Whitney U-test. So you use Mann-Whitney U-test when you're checking for differences in two means. That's part of an inferential statistics, not descriptive now. So in this case now, we looked at different lab parameters and we're checking how the medians differ between those that took the TZZ, which is a treatment of COVID only group, and those that had a combination of TCZ plus RODV. All right. So in this case, we had 511. In this case, we had 199. So the mean here was higher than the mean here for average IELTS interleukin 6, which is one of the measurements for COVID. So here you can see that the p-value was significant, 0.007. That is less than 0.05. And the z-test, which is our value for the Mann-Whitney, was 7.39. So you can see that those that took TCZ only had a significantly higher average IL6 compared to those that had TCZ plus RODV. So this table is an inferential statistic. You are now making inferences. All right? You're now making inferences that the average IL6 increased because those that took TCZ only had more of this IL-6 compared to TCZ plus RODV group. So that's an inferential statistics. So in inferential statistics, you are able to infer why you think one value is higher than another. Okay, why you think one value is higher than another. But for descriptive statistics, you can't do that. You talk about the result and you move on. You don't have to infer anything. It's only inferential statistics, like in this example I gave now, we can tell you and say, oh, this is the reason why this is higher than this. All right. So you can infer that the reason why we have a higher IL-6, in one group compared to the other is because one group took only one aspect of the drug, while the other group took two components of the drug. So that's inferential statistics. You're now making inferences. But in descriptive statistics, you're not allowed to make any inferences. You just describe the data the way it is and you move on. So this is a visualization for descriptive statistics. So we are still describing the data. From the pie, we have a data that shows the prevalence of tinnitus that's ringing in the ear. You can see that 38% of the participants said they had tinnitus ringing in the ear, and these participants were actually musicians. Then out of that 38% that said they had ringing, it was now analyzed how the ringing was, the frequency of the ringing or the pattern of the ringing. So find out that a smaller percentage said very often, and also once or twice in a month. A larger percentage says very rarely. So this is still descriptive statistics. We're describing the data. But in this case now, you're not able to tell why 38% had tinnitus or why 62% does not, because it's just descriptive. No inferential component in it. So you won't be able to infer on why the result is the way it is. Like in the example I gave you, you can actually infer why IL-6 was higher in one group than the other. You can infer the reason for that because it's obvious. But here, you can't tell. You're only describing the data. So why do we use visualization in biostatistics, especially in this case now where we're talking about descriptive statistics? It's easier to actually communicate things visually than in text. You can see the previous diagram that I showed you. You would agree with me that it was easier. Can we see the previous two slides, please? The one I did on the different countries. So look at this slide. You don't need a rocket scientist to tell you that the highest proportion or prevalence here is Nigeria. It's very obvious. Even if you're sleeping and you wake up and somebody just tells you, what is this chart saying? You'll be able to say something. Say, I see Nigeria on top. If you say nothing else. And I think it is followed by Senegal and Kenya. So figures and chart makes things very clear and easily identifiable. And the communication is faster, The same thing with the next slide that follows after this. Looking at this, you can tell for sure where the yes is and where the no is. Even looking at the slices, you have a clue that the no has a bigger slice compared to the yes. So, which is telling you that the prevalence of those that do not have tinnitus is more, because their slice, which is red, is more than the slice, which is blue. So visualization is very powerful. It just tells you exactly what is happening just looking at it, So it helps transform the numbers into insight. So looking at those numbers, you are already getting inspiration of what is happening. You're already seeing a pattern if one exists, which helps to facilitate communication like we're doing, right now. So we can easily look at those visuals and we can easily tell what is really, really happening. So it makes life easy. It makes things easy to understand. It makes it easier for people to flow, which is why I usually recommend for students, when you're doing a research and it's time for you to present, like in my college, we usually give students 10 minutes to present their work. So what I usually encourage my students to do is track your specific objectives, because every research you do have the aim and it also has specific objective. See if you can present the findings of your specific objectives visually, because oftentimes you will have like 5 specific objectives, especially for undergraduate and masters. It's usually PhD that they may recommend you to have more, but it's not cast in stone. Sometimes it may be less. But if you have 10 minutes to make a presentation of your research work, the goal of that presentation is, what did you say you are going to do? And what you said you're going to do is in your specific objectives. Did you do it? All right. So one thing you can do is you can use 5 slides to represent your 5 specific objectives. So the first specific objective, you have a visualization to show that you address that objective. The second slide, for the second objective, you have a visualization to show that you address that second objective. So you probably have like 5 slides with 5 visuals that are addressing your specific objective. So at the end of the day, your audience are aware that you had said you're going to do this and you had demonstrated that you actually did it. So visualizations are key because they make things easy and for people to actually understand, making the communication seamless. So there are common visualization techniques. So you can use histograms, especially for continuous variable. You can use box plot. Yeah, sorry about the mix-up here. Then you can use the bar charts, which is usually used for categorical variable. Yeah, next slide. So bar chart, oftentimes you can use them to tell what is happening. Like sometimes you may have disease surveillance or disease incidents. Okay, so you may be able to tell, okay, in these different age group, where do you have more of the disease incidence, or where do you have more of the disease prevalence? Like you can see, it's showing us that we have a higher box in 60 plus. So we'll be able to tell 60 plus, we have more disease incidence. Now, one of the difference between the incidence and the prevalence is incidence is usually over time. So when you're looking at how disease happens over a duration of time, 5 years, 10 years, you're talking about incidence now. But when time factor is not in it, you're talking about prevalence, okay? So this is an example of a visualization. So I have down there disease incidence, meaning you're measuring disease over time. So looking at this chart, you can just tell, oh, it means the disease incidence was more in those that are 60 years and above. So the visualization just tells you exactly what is happening here. It's no rocket science. Where you have the highest bar is telling you where the incidence is more, and which age group is there. It is those that are 60 plus. So I just added this just for us to maybe have some reasoning. So if you want to show trends or you want to show changes over time, line graph is better for doing that. If you want to show how something increases over time, line graph is better. So in this chart, you're looking at the heart rates. how the heart rate increases over time. So you can use a line graph to actually show that. All right, because you're dealing with numbers. So once you're dealing with numbers, you want to look at trends, line graph is the best. But when you're dealing with categorical variables like what I showed you earlier, categorical variables, then bar chart is the best, especially when you are dealing with 3 or more of these categorical variable. You can represent this figure 2 in pie chart as well, but when you begin to have more than 4 categorical variable, it becomes clumsy in pie chart. So bar chart becomes easier because it usually gives clarity. All right. So looking at this figure 2 now that is comparing study method, you have self-study, you have group study, you have tutoring. All right. Self-study, group study, tutoring. So these are 3 different study methods. Now, looking at the percentage, maybe we want to look at which study method does students use mostly. It has a percentage from 0 to 100. I mean, looking at this, you can tell which study method students use most. The chart is telling us they use tutoring most, followed by group study, followed by self-study. So the chart is just telling us students will prefer people teaching them. They will prefer a mentor, they will prefer a teacher teaching them. Then the next one they will prefer is when they are in a group study, but they least prefer self-study. So it means that students do not like to self-study. They would prefer being in a group or being taught by someone. So that's what this figure is showing you. So when you want to represent figures that you represent in percentages like categorical, the bar chart is better. You can use the pie as well if the values are not many. But for numbers you want to dictate or see changes in over time, then the line graph is better. So how do we integrate the descriptive statistics with the public health principle? Sometimes you can use it for population assessment. You have to appreciate the fact that we cannot improve what we cannot measure. So for you to be able to carry out an intervention in a community, you have to do a needs assessment. And for you to be able to do a needs assessment, you have to design a tool to collect that data. So when you collect that data, then you would be able to analyze the data and you'll be able to have a baseline. For example, now you want to carry out maybe like a health intervention for children in a community that you think they are malnourished. You cannot tell a child is malnourished just by looking at them physically. It's not all the time you can tell that a child is malnourished by looking at them physically. So for you to carry out that intervention, you have to be able to tell that the child is truly malnourished. So what do? You have to collect the data that are needed to measure nutritional status. You know, the BMI and the rest of them, the waist circumference and all those things that are collected to measure students' nutritional status. It's from that measurement using the WHO criteria that you'll be able to tell whether the child is malnourished or not. So from the analysis, you're able to tell if a higher percentage of the children have nutritional disadvantage. So if that is the case, then you will now be able to provide an intervention, all right, to boost their nutritional status in the community. Maybe educating the mothers, maybe providing them some empowerment and resources to be able to feed the children well. But in a nutshell, you will not be able to improve what you are not able to measure. So the descriptive statistics in this way can at least give you a preliminary result of what is happening in that environment. All right. You can also do health equity analysis where you're able to stratify, based on socioeconomic factors, based on race, based on ethnicity, and you are able to tell which group is suffering more than the other group. All right. You want to provide the same intervention in a community, you'll be able to tell, is it children that are suffering more? Is it elderly people that are suffering more? Is it this ethnic group that are suffering more? Or is it people of certain socioeconomic status that are suffering more? So this sort of baseline analysis can actually help you plan health equity analysis to know which group to provide more intervention for. And also evidence-based policies, all right, which helps in carrying out any form of intervention effectiveness that you want to do, or any form of developmental project that you want to do. Like I mentioned in the first instance, descriptive statistics can at least give you a springboard, a foundation to actually build upon in terms of data collection and analysis, to be able to see at least pattern of what is happening, so you can actually carry out whatever intervention that you want to carry out. So it can help. It's so unfortunate that a lot of times, especially in an area like mine, where you have politicians come into a community, they just tell you what they are going to do for you without carrying out a needs assessment to actually know what the community really needs. You now find out that because they don't do a needs assessment, most of the project they end up doing or executing, the community don't need it. So those projects now becomes abandoned projects. So needs assessments are very important, and something as simple as descriptive statistics can help you achieve that. So what are the takeaways for you? Descriptive statistics and visualization techniques are foundation. These are more like the first stages of your data analysis that can help you see patterns. Then you can know how to proceed if you want to do inferential statistics. You can't begin to do associations without doing descriptive statistics first, to actually at least see the pattern of what you're associating. For example, now, like the example I gave you initially, you're doing a study where you're checking for prevalence in preeclampsia. Imagine you have done the descriptive and you find out that the prevalence of preeclampsia is 1% in the population. With 1% in the population, I don't think that there will be need for any inferential statistics, because it will not come out well. So let's assume that you had surveyed 200 persons and only 2 women out of that 200 were tested positive for preeclampsia. 2 out of 200, there will be no need for an inferential statistics. There will be no need to begin to look at associations of what is making them susceptible to preeclampsia, because the prevalence is very low, so nothing will come out. So you see, just by doing the descriptive first, you know whether you're going to go further to begin to check for inferences in that study. It helps for clarity in communication, especially using visualization, and also evidence-based action. Evidence-based action simply means actions you take using data, not like politicians that make decisions without using data. Those are not evidence-based. That's why most of the things they propose don't work in these communities, because they don't use data to make these decisions. So evidence-based data promotes evidence-based action, and community people will most likely support your project when the data you use to carry out that project came from them. So it's very, very important. All right, thank you very much. So we wait for your questions now. So I've been seeing this hand up. I don't know whose hand is this. Would you want to ask your question first?
Okay, I want to ask my question. Like thank you very much for the impressive and for the enlightenment you have given to us on this descriptive statistics. The teaching was so thoughtful, like it was so clear. It was done with precision. All right. But what I want to ask this question, that what kind of tools can we use, in visualizing our data? Do you have any tools that you can recommend for us?
Yeah, so for visualization, you can use Excel. Excel can do like most of those visual, at least one or two of the visuals I showed, they were done in Excel, Microsoft Excel. Microsoft Excel has this section they call, just a second. If you open your Excel sheet, if you go to insert in your Excel sheet, you will see charts. In your Excel sheet, you will see charts. You can do really nice charts in Excel, using those charts. So once you put the data and you go to charts, it will be able to create charts for you. You can also use Google Sheets too. I use Google Sheets sometimes to actually create chart. That means the online version of the Excel. It can also create nice chart. Another thing you can use is Arrow, using chart, using the visualization packages, ggplot, ggplot2. So they can actually help you create, like the visualization you saw, the one for different countries, they were created using Arrow ggplot. So yeah, so you can use, I know people recommend Tableau, but Tableau is not free, but I heard there are some components that you can use to do visualization for free, but Arrow is free, and most of us have Excel, so you can use both. Yes, it can give you really nice chart. Yeah,
Okay, thank you very much, sir.
thank you.
And I want to also ask that after today's class now, we should be looking out for other aspects, are we? In the next day, or we will still continue this descriptive statistic tomorrow. I'm very sorry for asking this. This is my first time of joining, please.
Yeah, I know that the lectures are scheduled once a month. We have another one for August where we'll be looking at inferential statistics. So that inferential statistics will be in August. The date will be communicated if you have registered, for these sessions. Yes, all registered members will be informed on the date for the August session. There we will look at inferential statistics.
Okay, thank you very much, sir.
Thank you too. So any other question?
Yes, please. Hello, everyone. So just very quickly, outside of the monthly trainings as this, do you have mentoring sessions or anything of sort?
Yeah, I think the organizers would be in a position to provide clarification on that. Thank you. Um, it's anyone jumping in from the organizing arm on this question? Okay, so from my
Yes, good
own,
evening.
hello?
Hello, good evening,
Yeah,
everyone. Yes, we are going to
yeah.
be having what we call BRM clinic, that is Biostatistics Research Methodology Clinic, where our questions, our problems can be brought. We can consult experts on the field to guide you, to assist you as regard area of your biostatistics. So there is still a program coming up, and that is the announcement that is shown on the screen. And there will be a short clip also to explain this further. Thank you.
Yeah, thank you very much. So we would hold on for that clip, please, before we leave. So any other questions? Please take opportunity and ask your questions. Our time is running. Do we have questions in the chat? Can I take a look? Do we have questions in the chat? If you ask the question in the chat, could you please unmute yourself and ask, in case we're not able to take any question from there? Yeah, I see two hands up. Please go ahead and ask your question. Yeah, I see two hands up. Please, you can unmute yourself and ask. Blessing and Dr. Nura.
Hello, good evening.
Good evening.
Hello, good evening. Yeah, this
Yes,
is
good evening.
Aderomu Emmanuel. I
Okay.
I just want to ask this question. Say I designed a Google sheet, a Google
Okay.
form, yeah,
Okay.
for data collection for
Okay.
a surveillance activity, animal disease
All right.
surveillance activity for a particular state, for Ogun State. So now, one of the challenges I see, because I know you made mention of the fact that you can use the Google Google sheet for
Yeah.
your descriptive analysis now. So, but one of the
Okay.
thing anyway, one of the things I discovered, and is quite challenging for me, is that the the kind of analysis, the kind of descriptive analysis, the Google sheet, going to the responses now, and then trying to see the analysis, the preliminary analysis, the Google sheet, the Google form we present to me. It's sometimes quite confusing, because
Of
sometimes
course.
it's pretty difficult. Aha. So
Yes.
now but I would have loved that it would be that easy, but eventually what I do is just to export it to Google, to Excel, to Google Excel, then and then edit, do whatever editing, and then send to the Microsoft Excel, and then finish up my analysis. But is it not possible? Is it me that am I the one that made it look that way? Because I was expecting honorary it should analyze for me, and then I should just pick, export it.
Well, yeah. So the thing is, what I meant in my statement is you use the Google form itself to collect data, but it's not a good platform for data analysis.
Okay,
Fine,
okay,
it can give you a summary, show you some nice chart and the rest of them, but when the data, I mean, it's easier when you have like 5, 6 participants, 7 participants that have filled.
okay,
It looks really nice. But when
okay.
you now begin to have 50 field, 100
Mm,
field,
mm.
the whole thing will not look nice anymore.
Le-
So the best bet is to export the CVS file it creates
Okay.
and take it to
Yeah.
a statistical software to actually get what you
Yeah.
want. But Google Form is not a good place for any
Okay.
form of analysis. Yeah,
Okay.
yeah.
All right.
Mm.
Thank you.
Even
Thank
if
you.
even if it gives you that first few
Yes.
that looks good, but that only happens when the number is small. But
Small.
when the
Yes.
number becomes large, it can't
Mm,
manage it anymore. You know?
Yeah. That's true.
Yeah,
That's true.
yeah.
Thank you very much. Thank you very
Thank you
much.
too. Yeah. Someone else had a
Sorry. Let me ask
yeah,
another question. You talked about the
sure.
inferential analysis.
Statistics, yes.
Yeah. So now, if we're talking about, let's say, animal disease surveillance in the state, take for example bovine tuberculosis, and after um, using the Google form to get your data,
Mm.
exporting to the Microsoft Excel, and then finishing up your analysis, you now discover, can't we make inference? For example, say prevalence of bovine tuberculosis, for example, and then for um for few months, let's say 6 months in a year or quarter or something. So then can't you use that to make some inferences or something?
You can use that to make inferences. Inferences. Oh, sorry, could you mute? So much noise. Uh,
Okay, sorry.
Thank you. Yeah. So inferences are feasible when you have two variables together. You would notice the difference between descriptive statistics and inferential statistics. In descriptive statistics, you're dealing with one variable at a time. But in inferential statistics, you're combining two variables and looking at how they differ. So in your own case now, if you have a prevalence of a disease, that is one variable, and you're bringing time, how they differ in different months, that's a second variable. So you may have the different months, January, February, March, April, and each of those months, you can have the prevalence of the disease. It has moved from descriptive to inferential because now you can be able to infer which month has a higher prevalence and why you think it is higher in that month. Maybe because it's rainy season or it's dry season. That's inferential. But in a case where you have just the prevalence, it is high, it is low, you can't tell, oh, you think the prevalence is high because of this. No, unless you are associating that prevalence with another variable. That's the only way you'll be able to tell the reason why that prevalence is the way it is. But as long as it is just one variable standing on its own, you can't make any inferences. You just describe what you saw. It is high, it is low. That's it, you move on. But when you now compare it with another variable in your example, like months, yes, you can infer, oh, it is high in this particular month because you think the rain was more there or the sun was, so inferences now comes in. So two variables associating will definitely give inferences. But when you have only one variable at a time, it's purely a descriptive statistics.
Okay, thank you.
Yeah, someone is asking more examples on how to use data and conduct needs assessment. Well, I don't know how to give more examples, but the reason why you may want to conduct a needs assessment is simply because you want to carry out an intervention in a community. So for you to carry out an intervention in a community, it is not good to assume that this is what the community people needs. So a needs assessment is basically, I want to do something for this community, but I want to hear from you what you really need me to do for you. That's a needs assessment. That's where a lot of our politicians miss it. I'm sorry I have to be using them as an example because they are the ones that really fall short of this. They come into a community and they do a lot of wonderful things, and you find out that the people are not happy because that's not really what they want. You are telling them what you think they want instead of asking them what do they want. That's what needs assessment is all about. Putting in a survey there, asking them some questions for the community to tell you exactly what they want. It's like you wanting to do a research, and that research is going to involve parents, that research is going to involve children, and you don't bring the parents in the picture. They are not part of the co-design of your questionnaire. They understand the context of the community better than you. You don't bring them in. One day you just show up and say, oh, come and do this, come and feel this. And you wonder why they are not interested. You see, so you need to bring people in. in what you need to do before you carry out any form of, intervention or project. So is it not possible to demonstrate how you generate the visualization with any data set you might have on your computer? Well, it is the easiest one that can be done is it's Excel. Excel is the easiest one that I can do now and show you, which is quite easy. Can I share my screen? Is it possible to share my screen so that I can show them in Excel how to do this? It's very easy.
Please share, please.
Okay. So let me share my screen now and show you. Okay, so hold on. You'll be okay. So just a second. Let me find, because I want to use Google Sheets to do that. So just a second. I'm going to be using a lot of us are in Google, so let me share now so that I can show you what I mean. Just a second. Okay. All right, so let me share now. So just a second, I'm sharing my screen. Okay. So I'm showing us Google Sheets. I don't know. Can you see my Google Sheets? So this is Google Sheet, like a spreadsheet, but in Google. Can you see it?
Yes.
Yeah, sure.
Yes, you can.
So good. So once you open your Google Sheet, you can go to blank spreadsheet. So this is blank spreadsheet. So you can click on blank spreadsheet. So when you click on blank spreadsheet, so this is what you have, right? This is blank. So let's assume that I'm doing a study on preeclampsia. Now, that preeclampsia is to test whether they have preeclampsia or not, which will give you a yes and a no, right? So, and let's say a yes probably gave us a prevalence of maybe 25%. Then the no gave us a prevalence of maybe 75%. So both of them totals 100%. Yes and a no. The best visualization that I can put is pie chart. There's no rocket science about it. Pie chart will represent this very well. So how do you visualize this? It's simple. You just highlight it like I've done. You go to insert. So you click insert. In these options, one of the options is chart. Okay? This one of the options is chart. So just click on chart. Then when you click on chart, it's going to show you this by default. Okay, which is pie chart. But you can actually change it. If you don't want pie chart, you can come here and change it to any chart you want. I can change it to this if this is what I want. If I don't want this, I can change it to this if this is what I want. But in this case, I want a pie chart. All right. And you can see the yes is 25, the no is 25. So this is looking small. You can increase the size if you want. By double clicking on it, it will give you font size. So you can come here and increase the size to like 16, which makes it higher. You can make it bold if you want. You can increase the color to black if you want. Once that is done, the next thing is, do you like the red and the blue? If you don't like the red and the blue, you can double click on the red. It gives you the red color. You can come here, choose another color you like. If you don't like this, you can come here, change it to this color. If you don't like the blue, you double click on it. You come here and you change it to something else, maybe green or anything you want. So that's how it works. Okay, it's as easy as that. But if you want to title it, it's still very easy. You double click on it. It gives you an option. It's one of the options is chart style, pie chart, pie slice, chart and axis title. So you go this place and chart title, you can title it. All right, prevalence of preeclampsia. Sorry, prevalence of preeclampsia. Okay, so you have titled it. You see that it is in this corner. You can use this to bring it to the middle. It's in the middle. You can make it bold if you want. If you don't like the color, you can come to auto color and make it black. So that's it. So once you have done this visualization, you can download it as a picture. When you come up here, you will see 3 dots. You see these 3 dots here? Just click on it. One of the options is download, either PNG or PDF or this. So PNG is the best for picture. So you click on it, it will download it for you. That's it. You can open it. That is your picture. You can copy it, open a Word document and paste it there, wherever you want it to be. This is the Word document. You can paste it. You have your chart there. Clean. So that's how the visualization works. So a bar chart, a bar will definitely be at least something that is more than 3 will give us a bar. So let's assume that you want to look at maybe stages of disease, stage 1, stage 2, stage 3, and stage 4 with different frequencies. So we can say stage 1, maybe the prevalence is maybe like 32%. Maybe we'll look at stage 2. Stage 2, maybe like 48%. Maybe we'll look at stage 3, maybe like 72%. Sorry, stage 3. Stage 3. Then maybe we'll look at stage 4. 4, maybe another 89%. So as the stages is increasing, probably the percentage is increasing. It doesn't have to be, but this is just an example. So because it is 4, maybe we may want to use a bar here. So what you do, you highlight on it. That's all. You go to insert, you go to chart, you click. At first, it gives you a pie, but we don't need a pie. We want a bar now. So you can change it. So you just come here and choose a bar. Either you want this type of bar or you want this type. Whichever one you want, it's fine with you. So let's just choose this one. So this is what we want. So you have your stage 1, stage 2. So it just shows that as the stages is increasing, the numbers are increasing. So what do you do next? You need these numbers inside this chart. So what do? You double click on it. You double click on it and you go down. You will see format data points. So if you need error bars will come. If you need data labels, it will come. Those numbers that are there. If you need the thread lines, it will come, depending on what you want. But in this case, it's the data label that we want. So it is white here. If you don't like it white, or if you want it in another color, you want it bold, you can click on that number. Once you click on that number, you have options. All right. Once you click on that number, you have options. You can make it bold. You can choose a black color if you don't like the white. All right. You can do that for all of them. You can make it bold and you choose a black color depending on what you want. All right. If you click on it, you can even choose where you want the numbers to be, the position of the numbers. If you want them to be in the center, you can choose they will come to the center. All right. If you don't like this color autofill, you can change the color. All right. You can label this, and like I've shown you before, you just double click on it, and one of the options when you double click on this chart is it gives you opportunity to label. All right, which is you go to customize chart and axis, chart title. Then you can type pattern. This time it can be pattern of disease stages. That's it. So it's there. If you want it in the middle, you just come here, you go to the middle. If you want to bold it, you come here. If you want to change that color to black, you can come here and choose black. If the font is too small, you want to increase it, you come to font size. 14 is small. You can go to 18 if it's not too big. You can go to 24. Maybe you like this. And you can label the horizontal. You can also label the vertical. It's up to you. I have labeled using chart title. I can say, okay, I want to label my horizontal axis. I choose horizontal axis and I call it stages of disease. I've labeled it. I can make it bold. I can make it black. It's already black. Then I can also label my vertical, which is the percent. I can say vertical axis title. I can call it percent. All right. Then I can make it bold if I want. I can increase the size if I want. So once you're done, you can click on this and also bold it if you want. So once I'm done with my visualization, I can download it. I can click on these percentages and make it bold if I want. Then I'm done. If this percent and stages are too small, I can click on them and increase the font size to 16 if it's too small. Then when I'm done, I just click here, go to these three dots and download it as a picture form. Then click on it, open it, copy it, and paste it in the Microsoft Word. Go to the next page, break, and paste it there. I have my second chart. So it is easy to actually use the Google Sheet to create your visualization. I think this is the easiest that I can show you right now because of our time. Yeah, I hope this helps. Thank you. Okay, so
Wow. This is wonderful. Are you getting it? Like, can we? I want to, make a request that during our differential statistic class, can we have something like this practical? Our
can
tutor.
actually have that. Yeah. So now since for that, I would demonstrate using arrow in creating visualization as well. Yeah, maybe I may incorporate that. It's because of time, Yeah, but since you're requesting for it, maybe we would show some demonstration using arrow to create some of those nice visualizations that I showed you. Yeah, we can do
Okay.
that. Yeah.
Thank you very much. Thank you very much, sir.
Thank you too. Okay, so do we have any other question? Do we have any other question? Do we have any other question? We still have like 16 minutes before we wrap up. Any other quick question?
Yeah, thank you so much, sir. But just wanted to find out if this class is being recorded and, if it can be made available just, for review, further review on our parts after the class.
Yes, I think so. Yes. If you're a registered member, yes, you will definitely get information on where to view. Yeah, later on.
Thank you.
Professor, thank you too. Professor Majid, I see your hand up. Prof.
Hello. Am I audible?
Yes, you are, Prof.
Thank you so much. That was a wonderful presentation. I just want to quickly remind our participants that when we started the sensitization in April, one of the take-home messages that I gave those who attended is the fact that if you are not a biostatistician and you have a serious data analysis to do, please consult with a biostatistician. Because a biostatistician knows what to do, how to do it, and why they are doing what they are doing. That is quite different from a data analyst who can just make use of a computer to analyze data. He or she may not understand what is it that I'm doing, why am I doing it. I'll share a very quick practical example. One of my master level students submitted thesis, and the presentation of the data is faulty technically, yet she paid the data analyst to analyze the data. So one of the things that we emphasize in this kind of presentation is that we are giving you valuable information such that if you lack background in biostatistics, you'll be able to appreciate biostatistics, and you also be able to communicate with biostatisticians when they do their job. So, but it takes a lot for someone to get to a level whereby you actually know the nature of the data. What is it that I'm supposed to do? I'll give you an example. She presented descriptive statistics for master's level research, and the data analyst calculated mean and standard deviation for sex, for religion, and all that. So a biostatistician will never do that, because we know that the nature of the data determines what sort of analysis is relevant. So that's just the quick reminder that I want to put out to our participant. Thank you so much, Prof.
Yeah, thank you, Prof. That is very relevant, and I can tell you too that I have seen that from my end. It is the misunderstanding. You know, when you do data entry, sometimes so that you want to do your entry faster, especially when you enter the data in Excel, you may want to do some coding. You may want to say, let 1 represent male, let 2 represent female. But in the true sense of the word, male is male, female is female. You just want to make your data entry faster. Sometimes you say, let 0 represent no formal education, let 1 represent primary, let 2 represent secondary, let 3 represent tertiary, you know. At that level, probably the data analyst, like he says, will be seeing numbers. And because he's seeing numbers, he assumes that he can run mean. The fact that you are seeing 0 and 1 and 2 and 3 representing categorical variables does not mean the categorical variables are now automatically become numeric values. They are still categorical variables, and they should be represented in frequencies and percentages, not in means and standard deviation. So yeah, so like Prof said, understanding the principles behind your scales of measurement and the rest of them is very, very important. I think I should have a slide. Yeah, because inferential statistics, which is our next topic, has a strong relationship with scales of measurement. The type of inferential statistics you do is dependent on the scale of measurement. I think I would maybe sacrifice one slide again, talking about scales of measurement again and how it relates, you know, to the type of inferential statistics that you're going to be doing. Yeah, so maybe that will help provide some form of clarification for our next class. Yeah, thank you, Prof, for bringing that up. Very, very insightful. Yeah, so any other question before we wrap up? We have like 10 minutes. I think something has been shared in the chat, I think, where you can rewatch the session on YouTube. Yeah, so any other question before we wrap up? Maybe one more question, as we have barely 10 minutes. Okay, so it seems participants are fine. So the organizers, you can make your announcement now and wrap up us. Thank you very much.
Building on those awesome FIRAT biostatistics sessions, we've created something truly special, a digital space just for you. It's called the Biostatistics Research and Methodology, or BRM Clinic. This isn't just another platform. It's designed to be your personal research partner, giving you the confidence and the tools to take your ideas from a simple concept to a published study. I'm sure you felt that frustration, right? Struggling with confusing stats, worrying about your study design, or feeling totally overwhelmed by the data analysis process. We built this clinic as the solution to all that. It's meant to feel like you have a whole team of expert biostatisticians and methodologists standing by your side, ready to guide you at every turn. And we've also put together a comprehensive library full of video tutorials, webinars, and templates. These are practical, hands-on resources that show you exactly how to write a protocol, determine your sample size, or structure your analysis plan. Plus, you'll find smart tools to save you time. Our integrated tools will help you instantly calculate the right sample size and guide you toward the most appropriate study design. We're also providing secure and simple collaboration, so you can upload your anonymized data and work seamlessly with your team and our experts. Now, I know you're probably wondering when you can get your hands on this. We're launching the clinic soon, and we're giving you a heads up. Before the full launch, we'll be sending out a link to a form where you can express your interest and tell us what you would like the clinic to help with. This will help us tailor our services to your needs. You'll also be happy to know that we'll be providing a mix of free tools as well as access to some of the most popular paid tools in collaboration with their creators, so our users can afford them. And here's a pro tip. Priority access will be given to our Academy members. So, if you haven't already, I highly recommend you join the Academy at firat.rw/academy to get first dibs on all these features. This clinic is more than just a service. It's a way for you to gain a real advantage. You'll feel confident knowing your research is methodologically sound and ready for publication. You'll save time and money by avoiding costly mistakes and delays. And you won't just get answers. You'll learn how you can. Mate your automating self. We're breaking down barriers, making high quality
Good evening, everyone. Thanks so much. We are glad you are here for us. Thank you. First of all, we appreciate our Dr. Felix Emeka Iham for the beautiful presentation. I will also thank our audience, because if you are not here, we won't be here. Thank you so much. I know we must have learned a lot from this presentation. So meet us next month again for another insightful program about statistics class, and watch out for the VRM clinic. Thank you so much for coming. We appreciate you all. Goodbye.
Thank
you all.
you.
Bye. Thank
Thank
you.
you.
God bless.
Thank you.
Bye.
Dr.
Thank
Felix
you.
Emeka, I am.
Dr.
I say thank you.
Thank you.
Thank you.
Felix Emeka. Thanks.
Yeah, thank you. Thank you to everyone. Appreciate it.